The final part of Chapter 6 talks about inspection. Inspection involves examining items to determine if it is good or bad, or acceptable or unacceptable. Just because we are doing inspection and can identify when a product is defective does not actually fix the problem. It only informs us of the fact that a problem exists. Inspection can also be expensive. For example, how do you know if a car's airbags are working properly? Well, you have to crash the car. That can get very expensive. Basically, any type of inspection that destroys the product, whether it is a finished product or a work in process, is expensive. Other issues that need to be considered include when to inspect and where to inspect in the process. So you have several different options of when and where to inspect within a given process. Obviously, some processes are more amenable to some of these options than others. The options include 1. At the supplier's plant while they are producing. Here you would need to have a very good working relationship or some sort of contract for this to work. 2. At your facility upon receipt of the goods from the supplier. How would you perform this type of inspection? Well, ideally, you would randomly select pallets or crates off of the truck and randomly select items from within it to inspect. Number 3, before a costly or irreversible step. Why would I want to inspect at this point? Simply, garbage in equals garbage out. I do not want to waste my resources on transforming bad input because I am guaranteed that the output will be bad if the input is bad. Number 4, during the step-by-step process. This is basically saying inspect at every handoff. Number 5, when production or service is complete. So when the product comes off the production line, test it. Number 6, before delivery to the customer. Now this one is different than the previous because the product could sit in a warehouse or a distribution center after the production is complete and before the product is needed to fulfill a customer order. And then number 7, at the point of customer contact. Again, each of these points where we can inspect have advantages and disadvantages to them. When collecting the data from inspection, we should be concerned about how it was collected and how good it is. Issues may include worker fatigue. This could be workers making the product as well as the inspector's fatigue. Another issue to consider is measurement error. How accurate is the tool we are using to inspect? How accurate does it need to be? And then we have process variability is another issue we should be aware of. Variability is inherent in every process. How much of the variability is normal or expected, we need to ask ourselves. We should also keep in mind that, again, you cannot inspect quality into a product. Instead, robust design, empowered employees, and sound processes are better solutions to maintaining quality. Source inspection is also known as source control. The idea here is that you look at the next step in the process as your customer and you want to ensure that you provide the perfect product to that customer. A common tool often associated with source control is the Poka-Yoke. A Poka-Yoke is a foolproof device or technique designed to pass only acceptable product on to the next step. My favorite example of a Poka-Yoke is the nozzle for a diesel fuel found at gas stations. The nozzle for diesel fuel is larger than the nozzles for common unleaded gasoline. The idea is that the larger nozzle will prevent a motorist from putting diesel fuel into an unleaded only engine. Interestingly, the reverse is not true. You can easily fit a regular gas nozzle into a diesel vehicle. Why? Well, usually if you're driving a diesel, you know it. So you put the right kind of gas in. But also, a diesel engine will not be ruined if you try to run it with unleaded gasoline. It won't go very well, but it won't be ruined. So when collecting inspection data, it falls into two broad categories, either attributes or variables. Attributes are discrete events or whole numbers. Often it's either good or bad. That is, it passed or it didn't pass, it failed. Attribute data does not address the degree of failure, only that it failed or it passed. Variable data, on the other hand, is continuous, that is, it can be fractional. Measuring things like height, weight, speed, or strength are capturing variable data. The data collected will then be used to calculate statistics, which will then be used to create the SPC charts. The SPC charts is what we will focus on in our next chapter, or rather, it's called Supplement 6 from your textbook. So that's what we'll be getting to next time.